I am building an antenna rotator, and one of the key parts is a worm screw that gears down the stepper motor and prevents backdriving from wind loads. The SatNOGS plan recommends the SLM process, but I wanted to see whether I could simply 3D print a functional version on an FDM machine. The challenge is the geometry. The thread profile creates a 70-degree overhang that extends for about 6 mm. In CAD it looks perfect, in the slicer it looks perfect, but the real question is, can you actually print it? Let me know in the comments how you would tackle this. I tried 6 different approaches. PLA without support produced droops and burrs on the underside of the thread. Scraping and sanding is unpleasant because the PLA gums up sandpaper and is hard to cut cleanly. The part is serviceable, but PLA simply isn't suitable for outdoor use, especially during a Texas summer. ABS printed cleanly, but the unsupported hour edge developed a rope-like texture and the down-facing thread surface is ugly. Despite deburring and filing, the part remains ugly looking, but it is fully functional. Tower-supported ABS prints easily, but removing the support structure is tedious. The underside of the threads is still rough and needs a lot of cleanup. The final part still looks bad, but it is working very well. High-impact polystyrene or HIPS is a perfect support material for ABS because the two plastics don't bond. In this approach, I will fill the threads with a HIPS spiral that supports the screw. In practice, the HIPS flakes off immediately due to thermal warping. I stopped this print early. It's a failure. Surrounding the screw with a HIPS tower avoids cross-material adhesion issues. Each material supports itself. The print succeeds, but takes a long time due to the constant filament changes. Removing the HIPS scaffold is difficult. The underside of the threads are still unexpectedly lumpy and require cleanup. Yet the part also meshes worse than the previous ones. And my filament change poop bin overflows with wasted filament. Splitting the screw lengthwise avoids support entirely. Printing is easy, but even small warping effects fit. The halves don't align perfectly during acetone glue-up, and the layer lines increase friction which affects performance. I am not happy with this method. It doesn't perform well and has a plane of inherent weakness. I tried smoothing the ABS parts in acetone fumes, but I didn't see meaningful improvements. I deem ABS unsupported and ABS with tower support to be functional. The parts require cleanup and they may look ugly, but they do perform. The HIPS tower works, but it is not worth the time and wasted material. ABS split and glue does not perform very well. I deem these two methods marginal. Lastly, PLA and the HIPS filled threads are not viable. If I need to print these parts again, I will try tweaking slicer settings. I hope that this will keep the ABS molten long enough to fuse the strands on the unsupported thread underside, without turning them into frozen spaghetti. If you have recommendations for extreme overhangs like this, I'd love to hear them in the comments. If appearance or precision matters to you, make the worm screw from aluminium or bronze on a lathe or a CNC machine, or use the SLA or SLM process as recommended in the original plans. But for my project, the ABS unsupported and ABS tower supported prints are functional, and that's what I will use. Stay tuned for the upcoming antenna rotator build video. Thanks for watching. See you next week.